Okay. That's a lot of glare. Does that help? Now I've got to work on the glare. Just finishing up this JDL. I think I got it all done. While we wait for some people to come up online, we'll finish this up. I need to get it back in the case before I pull the CT sounds out here. Oh, big ol' amp. So we will get this one amp back in the case so I can test it later. Freshen up the thermal compound here. Wasn't bad, but I'm just going to put a nice, amp's not super duper old, so it was still soft. It just I want a little bit of thin coat fresh on here. Make sure that all the touching I did, when your thermal compound is okay, is in good shape and everything, you don't have to go through and clean every bit of it off. It gets a mess. I clean a lot of it off, but the repairs I had to do on this one didn't seem to do. But you'll end up touching and you'll get it all over, and so I always put a nice fresh coat on to make sure that I didn't rub so much off. See how, like on that side, because I had it leaned up, I had wiped these off. But inside the case, it's still got some good thermal compound. But we'll just make sure it's got plenty. Because you don't want to overdo it. Most amps from the factory have way too much. And it can be a mess. I just need a thin coat. Just fill in all the voids. Does a better job of on uneven surfaces and stuff. Just a tiny thin coat like that. Alright. She's back in the heat sink. Need to tighten down these little screws. Put the clamps on. This should hold it. Oh, no. Before we tighten down the end caps, let's put in all the correct center screws here. Make sure everything's aligned, and then we can put the clamps in. So we've got a couple people. I don't know if it counts me as viewing, and so there's only one actual person viewing, or if I got two. When these live streams first start up, it seems like there's always two until we get going here. But maybe I got two people that just jump in really quick. I don't know. I know some guys might be watching the Sunday night game. I know it's already 9 o'clock on the East Coast, so some people getting ready for bed, but you know, you don't want to sit in your bed and watch your phone. I just wanted to show some of the CT sounds and everything and showing what a complete rebuild's kind of got to look like. I wonder if that centers up a little better. It's the other way. Both those are the same. Overhangs one way or another, I guess it doesn't matter. Didn't pay attention to if that was critical. Does not look like it is. Looks like this bar may be used for a couple different ones. Joker's Inc. Dude, I copied the link from the group. Yeah, I tried to get it. So we're just putting this one back together to get the stuff off the bench because I'm going to be testing it later. It should be all repaired. It had RCA issues and power terminal issues, but everything else seemed pretty good. So get this thing back together, get this junk off the bench while we're waiting on people to go in, and then I'll go through the CT sounds, show how to check the amp. You'll see the damage. I've already got it slightly pulled apart. I pulled the caps off of it so that so we can show the testing. Tried to save a little time, but while we're waiting, we got a few people already up and on. And like I said, Joker's on. I'm going to go ahead. I've done a power up test. I'm going to remove the power and ground for now. Guess that's going to get tested a little bit later. That anymore, and I can tighten these end screws up. So this one wasn't component style repair, it was abuse repair. The amplifier had been really abused and they broke the terminal stuff on the power, which required quite a bit of work to fix up those terminals so they'd be reliable. And then now this one, it does matter because it's covering up that holding the thermal temperature sensor there. And I want to get a little bit. I did not have that. Where did, oh, there we go. Yeah. Little fresh thermal paste right there. Make sure that temperature sensor is good to go. Edwin's on. Hello, Logics. Enjoy watching videos. They're really helpful. Well, thank you. I enjoy making the videos. You know, I'm not a professional at this. A lot of the guys that do this stuff for a living, you know, either used to work for one of the amp manufacturers or ended, you know, for a shop and then went out on their own kind of thing. Me, I do it as a hobby because it's enjoyable, stress relieving. It allows me to trade and swap with guys for amps that I want. You know, I'll find dead amps that I want, and trade them some working amps and swap other stuff, subs or money or stereos or tools. I've traded for tools that I've wanted. My little system of barter. So those were the cover screws. And we're about to get this done here. I'm going to go ahead and put these last screws in. This only had 2 cover screws. I'm going to set the screw in temporarily. Oh, these are actually the end cover screws. I will have to find some screws in my pile of spare screws. When I scrap an amp, I don't know if I have the baggie around here or not. Anyway, I keep the hardware off of it. Really smart thing to do because you're always looking for stuff, and I get it stripped down to the board. Try to keep the important parts that might help repair another amp. But some amps are just too far going. Jokers, I know a lot about electronics, but never learned how the inner workings of things work together or how to fix them like you do. What are they doing to the JL audio amp to fix it? Okay, so I explained, I think, most of it. Like I said, it was just from abuse. The RCAs were had been damaged, stuff like that. So this one wasn't necessarily an electronics problem. It was physical damage, abuse, people being hard on it, and so just stuff you have to take time to fix up. It's a fantastic one if you're just getting into electronics or know a little bit, have good soldering skills. Soldering skills is half the battle. Being able to do a good quality job of removing components and putting them back in correctly without tearing stuff up worse. Alright, this gets this thing off the bench and it's ready for test. Just longevity test it and make sure it's good. Alright, let's see if we can get this whole thing kind of in the camera shot. Yes, we can. Okay, so it's a CT Sounds. It's missing one of its end caps. It's got all that. So I'm going to go over from the beginning of what I do. Just to, hang on, let me get a drink here. Okay. So just to cover my bases, I try to do this at the beginning of every repair video, but I'm going to go in and I'm going to look at the, let's see if I can slide this down. Yeah, I'm going to look inside all the terminals here, and I'm going to make sure there's no spare wire strands, anything like that. Then I'm going to go to the RCA end, and I'm going to look down in here and make sure nothing is broken off in the RCAs. You might have to get a flashlight. This has got a piece of dirt or a speck of something, so I have to get out my old feller specs. Pair of tweezers here. Yeah, it's just dirt. So in doing that, and then we'll go through and check where the gain knob was. It was dang near all the way up. So I'll work all the knobs back and forth and then set the gain to the middle. Like that. Give me my little low pass filter. We'll work it back and forth. We're wanting to feel how those knobs are. I'll clean them when we're all said and done, but I'll set that at about 100 hertz. Bass boost was off. Hey, very good. Somebody did one right, and the subsonic was off. So that's good. Subsonic is usable. Bass boost, never. Never, never, never. So, here we go. Alright, let's get centered up here. So, power terminals are down here, and RCAs are here. So, let's go over how an amp is laid out here. So, power comes in through the power terminals, and you got your remote turn on. I gotta take the glasses off. So, this is going to be the power supply section. Now, there's black clips that hold all these FETs. We're out of focus, something fierce. There we go. That hold all these FETs on the heatsink. They're little black clips. I've already got them removed so we can do some testing. But power comes in. There's a power supply section, which is what these are. You can have just one big toroid. You can have multiple sections. This has got 4 small ones. These are filter caps, and they're right here. All these caps are. And they're filtering the DC that comes in here for a little bit of alternator noise before it goes in to the switching. So there's going to be a group of 4 FETs in this amp, a group of 4 FETs and a group of 4 FETs for this power, that power, a group of 4 FETs for that one, a group of 4 FETs for that one. They will switch and make AC, which will get rectified by these rectifiers along the side here, and then smoothed by these caps, which are called the rail caps, to make higher voltage than 12 volts from your car battery. And that high voltage is called the rail voltage, and it'll feed the output transistors that are here and here, and then is driven by the output driver board, which translates the signal down here from the RCAs in the end, and makes the sound output. And then the sound output is ran through some inductors and caps to smooth and get rid of any problems. This amp happens to have a relay which will click in to actually allow the sound, the speakers, to go out to the speaker terminals here. So that's one way it uses when it detects something is bad in its protection circuit. It can disengage this relay and disconnect the speaker out if, like, the speaker shorted. Sometimes that can protect it. So we need to get our multimeter, and I'm probably going to have to get my little small probes here. So I already know what's wrong with this amp basically, but I want to show. And let's get a brand new FET out so I can show what I'm doing. So here is a brand new FET, and a couple things on this style or the larger style. If they have a bare back metal tab, that tab is the same as the middle leg. So if you put your meter on continuity where it makes a beep, like that, and you put it on the middle tab and the middle leg, you'll notice you got continuity. So that's good. So what we're going to do is, on these FETs, we want to test from leg to leg. So we're going to test this leg over here and this leg over here, and through the middle leg. But we can cheat by putting on the back tab. So we would push here on the outer left leg onto the right leg, and that tested it, between the two. And then we're going to test there, and we just don't want any beeps. Beeps mean it's a dead short, and that's bad. Oop, there went a little clip. Doesn't matter. These are 3205s. That's what we're going to be putting into the power supply. It does not have 3205s, but I can already see if you was to look down in here. Let's see if I can get the flashlight on it. Just makes a glare. I can already see a FET that's got hot and exploded out the side, and there was the same on one of these outputs, and so there's a lot of this that's going to be bad, but we'll just go through and we'll check. Now, when you go to check FETs on a power supply and on outputs, sometimes when you first put it on there, it'll beep for just a second, and it's charging a cap, but that'll go away. But this one, it's not going away, so I already got a dead short. This is that blown up one. We know it's going to beep. And all these that are in conjunction with it are probably going to beep. And it's going to cause issues with all these others. So we're going to be changing out the power supply. CT Sounds used a UTC 70N06 FET. And I'm not sure what gate resistor they used here. It's hard to tell because most of them are burnt up. Looks like, watch out, bald head warning. Red, red, black. So what's that? 40 something ohms or something, 44 red. A 22 ohm. So I got 22 ohm drive resistor, which would actually work for the 3205s. These are a little harder to drive than the 3205s. We're going to replace them with some 47s. But we have the same problem. We test the FETs in the output section, and we're going to run into, if I can get it on there, a dead short that does not go away, so it means it's not a capacitor charging. So we know we got shorted FETs. So you have to match FETs. And when I say match FETs, when you buy them, they'll have date codes. So if I can lay some of these out here. So get this to focus. It's a little hard to see. Anyway, down here at the bottom of the FET is some numbers that represent a date code, and you want those all to match. This one is a 109B, and so the reason why you want those to match is because if these were all produced together, and we're going to be running some of these in parallel for each power supply, that it actually has four. Two of them are doing one pull, two of them are doing the other. So these have to be matched for each bank of those, because if they're not matched and there's a slight difference, whichever one has manufactured to be slightly lower on resistance will end up doing too much work. Electricity follows the path of least resistance, and they won't share the work correctly, and so the one that ends up doing too much work will eventually overheat and fail. So that's why you always replace FETs that are going to be in parallel with matched sets. And so on these outputs, this whole side and this whole side all have to be matched. Now if you had two batches, you could do a whole brand new batch matched of one date code here and one date code here. That would be fine. You could have a date code here and a date code here. That would work when they're all new. But if you needed 8, let's say this only had 2 transformers, and it had 4 for each, you could not do, you know, 3 of one date code and 1 of a different one. You don't want to do that. They all have to be the same date code. So let's see what check set is. Strictly, hey Cliff is on. He says, what's up? Then let's see, Joker says, so how do you know when the MOSFET or any other parts are bad when fixing the amps or power supply of the amp? And that was it exactly, the testing with the multimeter here, to find the short, and then we just assume all the others are bad. Now I use a little tester. After that, I got a little tester. It will test and tell you whether the component shows up as a FET or a transistor or whatever. Now it doesn't load test it at full voltage or full current, obviously. So use components. I don't ever use them for amp repair. Let's say we're going to take all these FETs out. I will test to try to find all the bad ones and any of the good ones, and I throw them in my used FET drawer. And so when I go to rebuild something, sometimes I'll put some known good FETs in a couple places to allow a test, so that if I accidentally blow them up, I'm not blowing up new, I'm blowing up some old used ones when I'm, you know, thinking the repair may not be perfect, or there might be another problem that I haven't been able to find yet. So just in case, I can stick those old FETs in there. So we're going to need, as I'm answering this other question, to start pulling this apart. So one thing we want to do is we want to make sure all these FETs, this has got a silicone thermal strip here, and we don't want to tear that up when we take this board out. So we're just going to bend the FETs ever so slightly forward. Sometimes they're stuck and you need a little help. But you want to be real careful with that silicone pad. There we go. And let's see, Edwin says, is it common that the gate resistors go bad each time the FET dies? A lot of the time it does. Not always. Depends on how fast the protection circuits kick in, but if it's on the power supply, there is no protection circuit really hardly that can save a power supply. Whoa, this FET right here. Let's see if we can get a little view of that one. That one right there is split into 2 pieces. It's going to be real apparent when we go to take this apart, because part of it's going to probably fall out. So we get these are the rectifiers. Now along this edge, something else I want to point out, because some guys will look in here and say, oh, they're all FETs. No, they're not all FETs. You got power supply FETs, you got rectifiers, you got output FETs, and then like here on the heat sink, these 2 down here, these are actually voltage regulators. And they're making a certain voltage for the drive circuits here, normally 12 volt, or these are going to be the plus or minus 15 volt for the opt amps in the preamp section. And then there will be other regulators, because this board is I think one of the S-Tech boards, so it needs 12 volt and 5 volts. So we've probably got a pair of regulators here for the plus or minus 12, I think it takes, and then there might be a plus or minus 5. Looking around, that might be doing the 5s, I don't know, we'll see. These can be plus or minus 12 to 15 volts for the opt amp, so it might be doing dual duty. They may have saved some parts counts, but Jason's on. So let's get the ends off. We need to do that. We need a wrench. So get this out of here and some things will be easier to point out. I should have had these ends already off. Wasn't perfectly prepared for a live stream, but we'll live stream for a little while. Got a Rockford amp I repaired that helped me out with a whole lot of learning. And I got that cover off, and that's got it's still got its top cover piece. So there's a lot of people out there that bring in amps that are missing all kinds of stuff, screws, everything else. Plastic baggie, guys, plastic baggie. Super simple. I've actually got one for the same sitting somewhere already because I got all the clips in it. It's way over there sitting on top of the bottom plate. But I'm just going to go ahead and slip the end in here. Get this thing apart. This end cap, I'm going to try to slide it out from the other side, but we'll have to look. This has also got the little ground wire behind here. And the remote turn on LED. And I got to turn in the speaker screws. And power lugs so that I get the end cap off. Alright. So got that off. So what we want to do is there is, let's see if I can get this far enough back. So there's a gap between the circuit board and the heatsink down here. And we want to look in there with a flashlight to see if there's any ground screws in the bottom attaching to the heatsink. The reason why is because that would keep us from being able to pull this thing out of its case. So there is just this nice little ground right here. So that was kind of handy. So now we just need to find the screws in the center of the board. So this is not a super old, you know, CT Sounds isn't super old anyway, but this is not a super old Korean style board, because the original Korean style boards did not have screws in the center. When they very first came out, a lot of them did not. And the problem is bass would make this whole board flex, and it would snap all the legs of the FETs and cause the amp to die. And so now they put supports in the center on all newer, more modern ones, because they realize that people are silly and mount their amps to their speaker box, and they either don't provide any vibration dampening isolation, or they don't reinforce and double up the speaker box enough so that it doesn't transmit a lot of the vibration to the amp. You'll just get those guys that's got the economy boxes, and that flex a whole lot when the bass hits real hard, and that will tear up an unsupported amplifier. It'll tear up a supported one also. Because even micro vibrations will eventually crack the legs of the FETs. So just continue down the middle here. I don't see one there. There's one right there. I think that's it. And we need to swing this fan out of the way just a little bit to get to it. Let's get room to get this thing back up and where you guys can see it real good once we've slid it out of the case. All this extra work just to get to where you guys can do it. I should have had this kind of all prepped, but I like a little bit to show how, even if it's a simple fix, even if there was a simple fix in this, just to get this stinking thing out of the case. I already did all the clips and everything, and that takes a while and stuff. It takes an amp repair guy a while. I'm going to slowly slide this. It came nice and free. I don't want to tear up the silicone or the silicone sill pads. They're expensive to replace. Slide it, watching those silicone pads real careful like. That is, RCA is not well supported. That's going to have to come off there. This end cap has got to come off. And I'm going to tear it all up. It's dual screw. Got that where it landed in my lap nice. The heatsink did. So now we're out of the heatsink, and you can see that we did not tear up the sill pads. And then you can see where this FET blew, and it's left some char. And I can't tell if that's dirt in some of the other places, or if it's a little bit of explosion char. Now, I wanted to show you, there it is. So you see this FET right here. That is part of it. And there's the other leg where it's blown completely in two. See if we can get the camera to focus up here. There we go. You see that sucker blown completely in two. And that's in the power supply. Plus we know we got a bunch of charring right here. So we're going to be replacing, it's going to be a complete rebuild of the power supply section in this one, because this is a 2500. It's a newer CT Sounds, so we want it in good shape. I'm not sure how, CT Sounds is affordable, I believe. So I'm not sure how awesome their board is, but we're going to find out. It does say CT Sounds on the board. I'll look at the bottom here. Get my spectacles because I'm old. It's a pretty board. Here's the spacers in the middle. That's not the bestest of solder joints. Look like they had a little struggle doing a good job with on the solder of the big heavy hardware, which a lot of places do. They don't want to overheat stuff. But we are going to go and we're going to fire up my big soldering iron and a little H2O on the sponge. And so what I do to remove FETs, if they're completely blown like this, super duper blown, we just go in and we cut them. We know they are just toast, toast, toast. Sometimes it is nice to, there's that one that blew in half. Let's see if we can, here's the other leg. Have to focus up here. There you can see it blew in half. There's the inside of that sucker. So that one was right crispy. You can cut all the legs off and make it easier to desolder, so you can do it one leg at a time. Because we're wanting to try to salvage maybe some FETs that did survive to use as test FETs in other builds or other repairs, not builds, or possibly even this one if we have once we figure out the banks on the output. So you've got two output sides. Looks like two banks of it. So maybe you've got 1/2 and 1/2. I don't know, we'll have to look. They're all connecting. No, they are connecting in different times. There. Outside. Middle. So that is two different ones. So you've got a high side and a low side for each one. So that's two sets. So you would have to have 4 FETs to at least test this. So we're hoping to get 4 good FETs. One to put in each high side and one to put in each low side. Just for testing of the signals. And then on the power supply side, we know there's 4 because there was 4 inductors. But we get heated up. What are they using for FETs in this amp? On the power supply, they were using 70N06s, and we're going to replace them with 3205s. And then in the outputs, they're using IRF 640Ns, and we got a whole stick of replacements there. Give me just a second here. So I've got the power supply and the output FETs, whole brand new sticks of them. All date code matched and ready to go. So why did this amp die? Probably too low of ohm load, blew something in the output, and the protection circuit didn't kick in fast enough to save the power supply. If you don't have any problems in the output section of the power supply is just blown, that means that the power supply is the weak link, and the output could actually put out a little more than the power supply could handle, but that's not the case in this situation. Something is, we definitely got a short that we read in the output, so it died. Protection did not kick in fast enough to save the power supply, which is very common. The protection circuits will at regular listening volume, but if you've got it cranked and it's hitting hard on bass and your subwoofer shorts out or one of these components fails during really heavy use, the current draw is so big that when that happens and it spikes, it just takes out the power supply. The protection circuit doesn't have a chance to kick in. Down at low volumes and stuff, when it's going and the current's not so bad, if something goes wrong, this power supply can continue to supply the new spike for the momentary moment for the protection circuit to go in and shut down the power supply and save it. So it all depends on when the fault occurs, and what kind of fault it is how it kills the amp. So we just take leaded solder with lead in it because it's got lower melting point temperature, and I get my big iron and I go across all 3 legs and I add to it, and that's going to lower the melting point of all those joints because they are made with lead-free solder, which has a higher melting temperature. And we want to lower this because we're going to be going back and trying to pull all 3 of them together. So you overdo it when you're removing it. You can bridge them, but you don't want bridges later. But to start out with, you want lots of solder so that they'll all heat up evenly, and the FETs will drop right out, basically. Yank all these FETs. This is the long boring part. If you watch other guys that do amp repair, like Bear Vids, he'll a lot of times bring you in on some of his stuff where he's already pulled all these FETs. I'm trying to show, let's go ahead and get the power supply ones out here. So I'm just going to take a pair of tweezers and be able to grab a hold of, and this is the one that was blown to pieces that we already cut out. So I'm just going to grab the legs out. We're not worried about the holes being unplugged. We'll clean those in a minute. But then I just grab one. If I need to add a little solder, I will. I'm using the edge of my soldering iron to try to catch all 3 legs. Get them getting hot. And the FET just drops out. And we're dancing across the tops of the legs. We're trying not to rest your soldering iron on the board. If you put too much heat into the board, you can make these traces peel up off the board. So by putting the heat on the tops of the legs here as best we can, when we're adding lots of extra solder or extra heat, we're trying to keep it in the component that we're trying to remove and the immediate little bitty bit of the pads, just so they'll drop out. And that's why we're bouncing back and forth and just letting them drop. We're not forcing anything because we don't want to damage vias. We don't want to damage the board. And they are just dropping right out, my friends. I just dance it across the tops of those. And blammo. So we still got good connection. Ask some more questions. This is a good time to chat. This is all the boring part, but now you can see we got a bunch of FETs out. And we're going to be able to go back and first test them with a multimeter, throw out any that are dead. These are the legs off that one. We'll just throw out immediately any that are dead. And then we'll run them on my little tester here. But let's just go ahead and show that in case we get interrupted in the live stream. I'd like this to be thorough, so it can be published and usable for somebody to help troubleshoot their stuff. So I'm going to go ahead and place my, oh, you guys can barely see that. I need a zoom in cam bad. I need a video capture card is what I need to get so I can have more cameras hooked up. But I'm just going to go ahead and test. So this one's dead shorted to the left leg. Same thing, this one's dead shorted. 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 We may not get a single one. And really, on the power supply side, because I'm changing it to 3205s, it doesn't really matter, but that whole pile, all bad. So we've got all of them out here. Now, both my solder suckers broke. So I'm down to using my good old-fashioned desoldering sucker bulb, which actually, now that I'm back to using it, I've kind of been enjoying a whole lot better. It's been doing a really, really good job. So to do these, you're just going to touch it, have this crimped, and try to get that solder sucked out of the hole super fast. And this may be where this does not excel. Yeah, I may have to fix one of my other ones up because it does not have a big enough tip and it is not doing a big suck. It was doing real good when I was doing little stuff like RCAs and stuff on that JBL, but it looks like it's not doing very good there. Hang on just a second. So both my solder suckers have broke. I'm gonna see if I can't maybe glue this back in for now if I take the O-ring off. Yeah. So let's use some E6000 and just make this permanent. Maybe I can get this to live long enough to take this apart. Let that harden up. While we're at it, while we're taking FETs out. So I'm going to go ahead and go down and add solder to these output FETs. Now we're not going to do the voltage regulators. We're going to check them for shorts. But normally they do okay. Not always. So it's always good to check. You have to, pardon me trying to not talk so much while I'm doing this. If I run my exhaust vent, you guys would just hear a super duper loud noise and that was it. Couldn't hear me talking. So I'm holding my head way back and blowing the smoke away from me. Normally when I'm doing stuff like this, I'll hold my breath and then let it all out to blow everything away and pull my head back before I take a breath in. I want to get a nice quiet, I'm looking for a quiet one or build a quiet one maybe. So let's got them all with some solder. We're going to add some solder to the side here. Just fall out. Dance them across the top of the legs with a little spare solder, and you don't want to force them. If you're forcing them, something's wrong. Sometimes, this is especially true on JL amps, their holes are so small that when they trim the legs from putting them through, oh, never mind. Something we don't have to worry about it. When you go to take out FETs, they're going to be at a certain height, and I will use cards, and you can put the card in there and you can mark it. Now we happen to be lucky that we're not taking out, we've got voltage regulators over here. We actually look like we got voltage regulators here, and we have all these FETs, and if you look, if I lay a straight edge across there, they're all the same height. So I've got these to determine the height of the install height of these. If you don't, if you got to take everything out, or where it happens to be, or if it's a two-part board or something like that, you can always just place a card of paper, card stock, put it on there, use a pencil to mark underneath there to set you a height on your paper, and that way you know that you're installing the FETs back at the correct height, so that the clips hold them in the correct spot and they're on the sill pad in the correct place. So Jason says he picked up a powered vacuum pump sucker off eBay for desoldering just because he's lazy. I would love to have one. Heiko, I've got a Heiko FX 888X or D or whatever it's called soldering station. That's my little soldering iron. And Heiko makes, I don't know if they make a super cheap one, but they make like their new one's a 300 series I was looking at or something like that. Seems like it might be usable, or I may need to go one size bigger. But yes, the desolder where you can just set it on there and it gets hot for a second, and you kind of go and you pull away and it sucked everything out. That is really nice. And one of these days I will probably have one, but not right now. The only reason why we're not working on the other house right now, trying to be finished with it, is because it is nasty weather outside here and we just don't want to deal with it. So my wife is inside doing a puzzle and I'm out here streaming to you guys. So there's all the output ones out. And we're just going to do a quick test on these with the multimeter. See which ones are bad, so we know what to throw away. Does not appear to have any shorts. You know what? It helps if you turn your meter back on. And let's get that in a shot. It would appear it has no shorts because I'm an idiot. I'm a goober. I didn't have it on. I turned it off. So let's try this again. That beep was me touching the middle leg on accident. There we go. Nope, that was me again. That's good. So it looks like all these from this side were good. That is fantastic. And the reason why I take them out in a bank setup. So we said there's two different power supplies that are parallel, or not power supplies, sorry, two different output sections that are paralleled here. We took all this one out. This must be the side that's got the shorted one. We took all this one out and we tested it. Now I'll run it through my tester, but because the actual fault probably happened over here, I feel really good about these FETs, as far as these will be excellent test FETs, and I'm not worried about probably them being out of spec. Now we'll run them on the tester, But I think this right here will be my awesome little group. This gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. Well, that ain't cool. I'm looking at this, and I got a 0T7K, a 0T7K, a 75Y1, a 0T7K, an MY5W, a 0T7K. These are date codes. 75Y1 and M's. So looky here, this CT Sounds had different date codes all in that bank. So what does that mean? Well, there's a couple things. If the board manufacturer is ordering enough of these in bulk, if they've ordered, which is very possible, back to back production runs, and just getting a different date code. So they're, let's say they're running 24 hours a day. At some point, that machine's still kicking these out, still producing all this stuff if they're running 24 hours a day, and they just, their date code changes at midnight. That's okay. That's hard for me and you to know. It's easier for a factory that their supplier is certifying that these are the same batches. So that can be the case. The supplier of these FETs could say, even though we're sending you different date codes, these are all from a big giant production run and they're all matched and going to be fine. Or the manufacturer of this board for CT Sounds has the more sophisticated test equipment that will do these at load and get all the parameters and everything, and they batch test all of them, and they will set all these groups of date codes over here because they all match, and this group of date codes over here because they all match, and stuff like that. So you can have mixed ones from the factory, because the factory has better access to the vendor that's supplying them, so they can get reassurances, or they have better test equipment. Now, when me and you are trying to fix these things and stuff, since we're buying them from an electronic supply house and everything, we always want to buy them in a sufficient quantity to get a stick of all match date codes, and that way we know and we don't mix them up. So, am I worried about this? Probably not. I know that I need one here and one here, one for the high side, one for the low side, and I need one here and one here, one for that high side and one low side. And so I've got 4 of the same date code. I actually have 5, but I'm going to be good right there, and I'll probably use 4 of those. That way I know they're all perfectly matched. If these all test good on my tester, and we're going to put that little pile over there by the tester. I'm going to clean up a little here. Like I said about thermal compound getting everywhere. That's just isopropyl rubbing alcohol, 90 plus on the purity. There we go. This is a Walmart brand. It's 91%. And then I just got a little sprayer top off. I can't remember what it's from. I think I had to cut it. I think it was from like a Windex or something. But anyway, I do that, and then out of the Walmart food prep area, like with cutting boards and all the spatulas and all the utensils, there was a little 2-pack of these that are stainless steel, and so I got them. And so with the spray on here, if I need a pool of it, I'll just squirt it in here. And that gives me my rubbing alcohol where I can dip Q-tips for cleaning, or toothbrushes. And the other thing it allows me to do is then pour out when I have my, and this is my small bottle I keep up here, but I got a big jug of acetone. I fill this little small bottle so that I've got less chance of making a giant mess with that big pain in the butt acetone bottle. But isopropyl for almost all the cleaning, and then acetone for final cleans and stuff. But that got all of them out, and I'm excited that those FETs should be good enough for our testing when we go to repair it. So one thing, I'm going to keep that group over here separate from this set of output FETs, because if everything tests good in there, there's a good chance that on this circuit board, this chip that drives this side and all this stuff should be fine. It's probably this chip that's damaged. Now I may just do both chips anyway, because that's kind of what I do just in case, because these chips are really fragile. But I'm feeling pretty confident that this side would be good, and if nothing else, what I may do is when I salvage this chip, I may be extra careful when I take it off. These are moisture sensitive chips, but I may make that extra careful, put a little orange dot on it or something so I know it's a salvaged one, put it in my bag with the moisture reducing stuff, so that I got one to stick on some boards when I go to repair them if they have other issues, maybe as a sacrificial test one, because these chips are about $3 to $4 a piece depending on where you get them. Have tariffs, taxes, shipping, you know, depending on what your luck is on getting some of them. So on this, you know, automatically you're at over $8 just if the chips are the only problem. Plus you still have to take this out, and that's a whole nother thing you have to use. You don't have to, but I recommend, because if you've watched any of my videos, you've seen me pull one via. But this is the rework alloy. Chip Quick is one of the name brands. This is the off-brand one called Remaloy 4.5. It's a few bucks cheaper, and it works just as well. So that's what I've been using. But that allows you to pull these boards without pulling vias, and I've just started using the heck out of it. I've kind of got spoiled to it once I got it. It costs money. It's expensive stuff. It's not the cheapest. So, okay, so yes, we have 4 rectifiers there, 4 rectifiers there. And these, if I get my flashlight, that's a 7812 and that's a 7812. And that one of them's going to be on the positive rail voltage and the other is going to be on the negative rail. So that gives you your 12 volt references for this card. These should be, if I can see them, 79. It's a little dirty. Get in here. 7915 and a 7815. So that's going to be your plus and minus 15 volts for your op amps here. And then these should be a 7805, 7905, and this one should be 7805. And there's your plus and minus 5 volt regulators. So the 78 and 79s let you know that. You can on these, which were the plus or minus 15s for this, a lot of times you'll see the LM317 and the LM337, which are adjustable voltage positive and negative voltage regulators. And they'll just have a few extra resistors and stuff setting their voltage to normally plus or minus 15 volts. So I am ready to take out, this is the power supply side, so we're going to go ahead and add the solder here. But I am going to need a 2-second break here in just a second to go refill my water, because I am getting parched with all this talking. So let's get some solder added to all these. And you know, I was thinking I don't have an intermission board. Maybe we can make one real quick for everybody to go grab a snack and refill their drinks. see if we make a new one. It's called Enter. We say OK, and we go to it, and then we add text. When we do that, does this work? Whoa, that needs edited. Does that work? Somebody tell me they can see the intermission. Go refill your snacks and drink. Anybody? I can see it. Okay. Wonderful. All right, we're going to do that. We're going to have about, I'm going to set my timer on my phone. So we'll be going no more than 5 minutes. Well, you can't see that for Jack Diddley. No more than 5 minutes. Should take me a little less than that. And I will be right back. Like I said, we'll fill up my junk here, and we will continue getting this last bank out, and then maybe test some of these FETs over here. But we'll definitely be hooking power up once all these FETs are out to check power supply drive waves, and so we will have the scope up here working and stuff. So all right, let me go do this and put you on mute. Alright. I don't know if my phone beeped or not. Oh, we still got a minute, but we will say stop. So I got me a spicy beef stick. That'll be my snack, but I'm not going to do any soldering until I eat this. I don't know about you guys, but I don't want lead poisoning. My stream is a little low. Oh, no, it's just saying the audio stream. Never mind. Because I had it muted. Okay. So we should be good. So Cliff's back. Yes, Anon. Easy, awesome. Watch a couple of my videos. They don't show the oscilloscope setup per se, but you do not have to hook actual real power to a Rockford Fosgate to test the power supply drive. The beauty of a Rockford Fosgate amp is you can hook the ground to it and the remote turn on 12 volt, and that will power up the little TL494 chips inside and allow you to check the drive without having to put main power to the amp. So when you do that, as far as for your oscilloscope settings, you got to learn a little bit, but check out Perry Babin's website, which is bcae1.com, I believe. Hang on. Yes, that is correct, and I think there it is. So it's basic car audio and electronics. And it's bcae1.com. And on here, he should have over on the side. You guys can't see it. There's a menu over here to the right hand side that's not showing up in this capture. Oh, maybe I can fix that. Yeah, there it is. Pull this over here. So he goes over tons of car audio stuff, and I believe there's an oscilloscope section. He goes over digital multimeters, charging system. People really need to read that one because of the power needed to run these big amps, and that's why it's really the reason why a lot of people kill a lot of amps is that they don't know it, but they keep cranking it up, and all of a sudden their voltage drops so low that the current that these things pull gets so high when the voltage drops that it ends up popping them. Well, there was a whole section on. There is a section on switching power supply, which helps you. Oh, yep, there it is. Whole section on oscilloscope right here. So we'll go to it. He talks about how to set it up here, and talks about some of the others and everything. Common features, all the different things. Kind of gives you a layman's term of all that. And Perry's got a paid-for guide on amp repair that most everybody that gets into amp repair gets. But you need to read everything that he has on the net here for free several times before you decide whether or not you want to do that. It is not for the faint of heart. You really got to get into it, and his free part of his website will give you enough basics that you can do some checks, and if you really read it and really study it, you can find out a lot of stuff. Watch a few of these videos and then make a determination if you want to buy his guide. I really recommend it if you do. If you're just interested for the sake of being able to test amps, which is a big part of what I do this for, so that you can, if you go to buy a used amp, or if an amp that you had blew, so you can do a little bit of diagnostics and determine whether or not it's feasible to send out for repair. Or if you're going to be buying one, make sure it's not already blown if you can't hear it play, which is very risky. But you can get good at testing them and know that pretty safe, even without playing them. But I've got my truck, or I did have, I got to fix it back up again, set up so I can I bring me some tools, and then I check out the amp, and then before I even hook it up to make sure it's not going to blow fuses in my truck, and then I'll hook up the amp, and I got a little test speaker that I use here at the bench, and I put a strap on it. It's just a little 10-inch sub, and I can carry it around with me and hook it up into amps and make sure they play and stuff and everything, and that there's nothing crazy wrong with them before I go to trading or anything like that. Okay. On the new primes, it doesn't work, huh, Cliff? Cliff is strictly amps. I have only had one prime in, and it was not for an amp fault. As far as all that goes, it was for somebody tore up the RCAs, and we had to fix them. So I get a lot of that. Another thing, secure your amps, people. I get a lot of amps in that I fix RCAs and stuff where the amp slid, or the amp was attached to the box, but the box wasn't secure, and they slammed on the brakes, or they were being dumb and they hit the accelerator hard, and their box goes sliding around in the trunk or the back and rips the RCAs out of the jack. So yeah, the amp repair guide is awesome. Even if you're not wanting to repair, but maybe just have a whole bunch of good background information so you can start recognizing better quality stuff, he goes through a bunch of things like that in some of the stuff, showing some of the better quality devices and things like that. That's how most all of us know to use 3205s in the power supplies now. It's just such a good FET. So sometimes it can increase the strength, doesn't make any more power, just increases the durability of the power supply section enough that if somebody was to drive this hard again and it pop another FET like this one did, the power supply could handle the extra current just long enough for the protection circuit to kick in, and then it would just be an output repair, which is nice. Makes it a whole lot cheaper. You know, if you have to do both these sections and plus all the little stuff, it's a lot of time and a lot of parts, so it can make them expensive. You know, I do a lot of amp repair for local competitors and stuff, and so I don't charge a ton for my labor. Normally I try to do swapping and barter. I like a little barter, a little swap and barter never hurts. So if they've got an old school Rockford amp or an old school PPI or Soundstream or something that they're no longer using because they went to all this Class D and all this other stuff laying around, and their Class D needs fixed. Then they will, then I'll try to get that for part of the repair. I'll have to pay for parts, obviously. I can't be that generous, but you know, I can do stuff like that for something that I want. There's certain amps that I'm looking for and that I want. I will have to take another intermission here in a minute. That was my mother. She's needing something that's close to the holidays, and so I'm sure it's a Christmas gift or need question. So I will have to take a call here in a second. She left me a voicemail, so let's go ahead and get these parts out. Oh, what is this amp? I don't have it because we don't have the other thing, and I would have to change this to edit it. Edit that, please. Yes, edit. CT Sounds T2500-1D. That'll show up. That'll show up when we're on that other screen, but it is a CT Sounds. Let's go ahead and get these FETs out. It's about time to redo my solder iron here. This may not quite be hot enough yet. Give it a second. So this is a Class D. It uses the 3S Tech or whatever style driver board. We'll be adding some chip quick type stuff, some alloy to pull it, but I'm going to mark the side that I think's good, just because I want to be able to save that chip. I'll probably end up be replacing both of them anyway, but I want to be able to save that. But my whole goal was to show tearing these things apart a little bit, talk about all the different parts so we can identify them. Talk about what we salvage and why we salvage it for testing purposes. And I'd at least like to show troubleshooting of the power supply drive, because we need to talk about you know, change the drive resistors, which these are all shot pretty bad. So they're going to have to all get replaced, which is going to be boring. And then testing the little drive transistors, which I think this one's on a board in the middle, so it could be a challenge. I may set that up for a live stream within the next day or so. If it gets too late, I know everybody's got to go to work tomorrow. I do. I don't want nobody to be tired due to me. Anon was talking about Rockford amps. The one thing I love about Rockford amps, and I was fixing up a newer P500-2, which I don't think I video recorded, because I've got a ton of newer Rockford amps to record of my own. This was not one for me, but it's funny because from like all the way back in the days of the DSM amps, and sometimes even from the hybrid design punch 45s and 75s and 150s, Rockford keeps building on the circuits and using the same technology still in them, just sometimes updating them, or you know, making it a little better. But they carry over a lot of the same features. Rockford had a lot of good features way before anybody else, and so, you know, they carry that over even into modern amps. So part of their protection circuits, stuff like that, are all the same. And repairing an older amp kind of teaches you sometimes the newer amp stuff, or repairing a newer amp and still even that technology was used way back then, so it helps on some of the old stuff. And so I really like working on Rockford amps. Now, I'm not an expert, so this came out of the power supply. Let's see if we can, and that sucker is blowed up. It's blown out the side even. So I guarantee that one's bad. But we've got all the FETs out. We've left in all the voltage regulators and all the diodes, the rectifiers. We're going to go ahead and get the meter back out here. And so we know this thing exploded, so just, yeah, see, it's dead there. That one's dead. That one's dead. So when I said it took out the power supply, it took out the power supply. So if this one's dead, and it is, so every FET in the power supply from both sides was blown. Completely and utterly blown. We'll go through these outputs here. That was me. Now, I had a blown output. Aha. So that one's bad. This one's bad. And you can actually see, and we can get it to focus, a little burn spot right there leading up to the hole where the little smoke out of the FET. So we got two dead ones there. Those go in the trash pile. I'm just going to look at these real quick to see something fun here. MY5, 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 OTK7s, MY5s. So we ended up with two dead ones. I don't know what they were, but this had a mixed batch. This may have been better if one of them was an MY5 and the other was a TO7K. They may have been better matched on this side. Like I said, for the repair guy, because he's not buying them in pallet loads, not getting assurances from the manufacturer or having the super fancy test equipment, just got to use matched. That way you know they're all equal. We're going to put this stack over here because this is from the side that was blown. So I'm less confident in those checking good or using them as replacements. As a matter of fact, if they look any bit out of sorts, I'll just chuck them, because I do have a pile from a side that did not blow, and that's what I like to have up in my used FET drawer is truly pretty much known good. The ones that came out of this blown side over here, which was just towards us, they're the ones I'm going to be suspicious about. And so I may not even want to have them in my drawer for testing. So this was the side that had the couple of blown ones. So I'm going to buy a silver Sharpie. Originally, I used to mark all my amps and stuff with, I'd get this blue painter's tape, and I had to buy a silver Sharpie to be able to write on it for it to show up, because black Sharpie was really hard to read. And you can see, you can write on that with that, and it's good. But the silver Sharpies are expensive. Well, now I get green tape, the green painter's tape, and the black Sharpies work real good on it. But I still recommend a silver Sharpie, and that is so you can mark FETs when you think they're bad or they need to be tested. You can put a little dot in the corner, or you can put a big X if they're bad, but you may need to keep it because you need to be able to, put an X on it, but leave the part number shown, because you need to know what to order, but you want to make sure you mark it as bad. So this was the side that was blown, so I'm just going to go on this chip with the silver marker Sharpie and just mark it real good to know that that was the blown side, because I'm considering maybe trying to salvage this good side one as a test chip for later, for when I'm worried about if I've had to do repairs on other parts of these boards, and I'm, you sometimes you get a little worried that you can't test everything with a meter. Sometimes you have to plug the stupid thing in, put power to it, and test it with your scope or something, and even then you find another bad component and it ends up blowing a piece. So it'd be nice to have one of these stuck in the dryer bag that I got with the desiccant, to have one of these as a spare test, just to give me a little peace of mind sometimes when I've had when these boards are more damaged than just those going out. So there's lots of things you can check, and we'll do that. I'll dedicate one, either whole live stream. I kind of did it on a couple of my videos showing how to check for the 12 volt, the 5 volt and stuff, and there is Places and Perry's guide, and then there's downloadable people have uploaded to various places on the internet the circuits for these Korean amps, and there's two different boards that are real common. There's the 2-driver one like this, and then there's the 4-driver one, which is in bigger amps, and you can see what those pins are down that hook to the board, and so you'll know which ones to measure to check your 12 volt, to check your 5 volts and stuff like that, to make sure you're getting what you need up to the board. So now we have everything good here. We need to carefully flip this back over, and we're going to take our cover that tells us B plus and ground, and make sure that we know which is which. So ground's on the outside, battery's in the middle on this one. I don't ever trust that it's the same. Even if I've worked on the same amp every time, I just double check, because I'm a goober. And if I didn't, I'd end up doing it backwards and then blowing more stuff, and then that's on me because I'm the goober. And so always check is what I do. All right. So now we have power and remote added, and we're actually cannot make any power, no rail voltage, because we have no FETs in the power supply. But one thing we do need to do is, since we've taken all the FETs out, is we need to touch all the legs, and I gotta get my glasses back out here, and make sure we don't have any shorts that we caused with solder. And did you hear that? And it beeped, and see how the number's climbing? That's charging a cap, so that's fine. We just don't want a permanent, long-lasting beep, which would indicate a short in between the legs. There it is, charging the cap. That was me. There it is, charging the cap. And you want to do this every time you work on an amp, because if you forget, you're going to blow something up, or you're going to pop your fuse on your power supply, or, like I said, worse, blow something up, cause more damage. Okay, so I have no shorts in between my FET pads. I do need to get a little bit of isopropyl alcohol and a Q-tip here. We have right here on this board a bunch of carbon sooting from where these resistors and these FETs over here went, and I want to clean that just a little so I can see stuff a little better. I cleaned up nice. Now these resistors are the gate resistors all along through here, and they are all burnt up, so they're all going to have to come out also. I'll probably do that off camera. Oh, maybe tonight, maybe tomorrow, I don't know. Try to get this up, but we can actually, that doesn't matter since we're not driving the FET. We can still do some tests. So up here, in line on my power supply, and we've got set for 13.5 volts. Oh, and I need to bring you guys to the live stream here. So there is the thing. So we're going to set this down to about 12.5 volts. That 0.074 current draw is from the radio that I have hooked to this also, that I use for testing. It's an Alpine, and that's just the memory remote. That is why it's got a little bit of current draw already. So we get our O-scope, and you can see the O-scope now. And so this amp does have this. Right here is the driver board. That looks like the TL495. Here is, may not be able to do any of that. Bald head warning. Oh, I have that flashlight too. Did I just kill my batteries in this? I think I did. I think I left it on. Grab my one. Have to replace the batteries. I don't have any flashlights going here. Crap sticks. Grab a pair of batteries. Yes, my test bench is still pretty, there we go, get the focus going on, pretty temporary. I still need to get everything set up here. No. It appears maybe my light bulb is burnt out. I'll look with my aha. There, I'm just getting bad connection. Alright. So those batteries are probably okay then. Gonna look down in here. So this card right here in the middle is the power supply driver card. I don't see up in here any FETs, but I do, or sorry, transistors, but I do here, and those look like there's 4 and 4, so they're probably what drive the power supply here. And I'm gonna, like I said, bald head one. Yeah. Can't tell. It's just goop from the factory. If that's burnt up, let me look here. Because they got some of this black junk that they put all over in the board. That looks like that's what that was on there. Alright, so if the transistors don't look blown up, you can do a test. You might have got lucky. They may have been power strong enough to survive even though the gate transistors did not, but normally they will not. So when you go to power this up, you will not get gate drive. Or it'll be all messed up. So let's see. The other thing being is somewhere, oh, right here. Here is, let me get this back a little bit so you guys can see it. There is the power LED. It's underneath there. So we're just going to go ahead and hit it with power for a second. And the green light came on. Did you see that? Oh, my power light. Things slipped out. A little better. So let's see. Get this back in the camera shot. There, you see it light up for a second. So, and you can see the fan spin. Watch. See if I can get that in the shot. Watch the fan spin up there. That's because it's over here on the 12-volt side. So nothing immediately going crazy. I'm watching up here on my power supply, and I heard the click from the relay. So everything says it's good because we took all the shorted and dead components out. Now, if you look up here, I'm pointing up at my power supply. When I turn it on, 0.2 amps, 0.3, 3.5 amps maybe. So we're not really pulling anything. So that tells me we probably don't have anything terribly bad. We're going to look here. I gotta find. Oh boy, looks bad. There we go. Okay, so let's turn. Let's go back to AC coupling temporarily. Turn up the intensity a little, and then turn it up a little more so you guys can see that. So can you see that square wave there? So there is one resistor I seen was good, and that is on the pad. Now this is before the resistor. Looks the same. This is before this resistor. This is after that resistor. I'm going through right here in a row. Notice before, and this is after, and that resistor got baked, and it is doing some weird stuff to the signal. This is before the resistor on this one, and it is bad. After bad. Before bad. After bad. Before, that's good. After, it's good. Before and after. Before, it's baked. And after. Before and after. Okay, so what does that tell you? Well, we have two sets of transistors here, 2 there, 2 there, and 2 there. So the transistor responsible for these 2 FETs and these 2 FETs seem to be good. The transistor pair that pull it up and pull it down. Sorry, I meant to say the pair. The other transistor pair that was for these 2 and these 2 are fried. So I'm assuming it's one or the other. We're going to have to determine it by taking some readings on there. So we do the same thing over on this other side of the board, and we can determine if these are fried. And by taking it on each side of the drive resistor, you can tell, like I said, this one, I want to show you that again. Here is, that's what it looks like on the FET side, but if you go to the driver side, it's fine. So we need to replace that resistor. We're going to be replacing them all anyway with 47 ohms, but let's go over here. And that looks terrible. We're getting nothing. Nothing. There's a nice drive wave. And we want to compare that. See that drive wave there from this side? See how small it is? See this drive wave here? How big it is? Something's amiss. So we got a really big one here. That's before. Nothing on that one. And then we go before the resistor, nothing. We go here, we got a nice big drive wave. Nice big drive wave. Nice big drive wave. So we have a couple issues. One, we got a bigger looking drive wave over on the good parts over here, and then some of them that are bad. And then over here, the ones that do have the drive wave, it's actually small and reduced. So some of the things we need to look for is things pulling those drive waves down over here, or something that's supposed to be pulling that drive wave down a little bit over here that is not doing its job, and so the drive wave's too big. So most likely it's going to be these drive transistors, and we're going to kill the power so that we can go through, and we're going to look and see what their part numbers are. So I'm just going to push that over. And get me a Q-tip to clean it off a little. And this one looks like it's got hot. Bald head one. I think that's the one that got so hot that you can't read on it now. So that one is an A1275. I'm gonna write that down. A1275. Bend a couple of these others back to see. There should be one that's probably a C something. I can't remember the part numbers right off the top of my head that end up matching. Oh yeah, that one is that one we were talking about, and that looks terrible on there, so I'm going to assume that it's probably bad. It may have actually been bad and not been goof in the factory. Oh, they both look so terrible. Let's look at these over here. I'm just bending it back so I can see down on the lettering. And there's a C3228. We'll write that down. C3228. And we just need to verify that A1275. C3228. Yeah. A1275. So we have all that in there. I'm going to draw me a little picture that shows exactly where each one of those goes and what it should be based off what I can tell, because those are all paired up for driving these 4 different small power supplies. And I'm replacing all of them. When I pull them and then replace them, that will ensure I should have perfectly equal setups on the drives. They should all show up right. If I don't, after all those are pulled and they're all from a matching batch also, then I know I've got some problems with pull down, either diodes or resistors or some of the snubbers or something else out here going on. So we still got 6 people going. So I do need to make a phone call. It is 10 o'clock, which means it's 11 o'clock on the East Coast. I'm looking up here at my $2330. Does it listen? No, not that one. So I'll have to look through my bags. If I do not have those, which is the A1275 and the C3228, which I probably don't, then I will probably go with my BD140 and BD139. I gotta find my sticker. My other sticker fell off, but that shows that when you look at it, it's a emitter collector base. Because when you replace these, you got to make sure that if you're not using the exact replacement to drop in, that you match up base, emitter, and collector, because there is some differences between some. These are physically bigger. Driver, let's see, do I have one I can snag? So the little transistors here are about this size, and these drivers that I use are about, you can see how much bigger they are. So they're more robust. They handle a little bit more current. They're less apt to pop, as long as they'll fit in the holes. So what I have to do is I'll have to desolder some of these, and then we'll have to see if one of these fits. If they don't fit, then I'll have to make sure I get either compatible ones or replacement original style to put back in there. But we will do that, and that will beef up the drive. We'll replace all the resistors with 47 ohm resistors so that they can drive, and we'll clean out all these holes, and we can put the 3205s in and get power up. And then once we have power, we can check all the voltages down here on this chip to make sure we got all the voltages in the right spot and correct rail voltage. Without taking this out and without having any FETs in, we should be able to see the low side drive on whatever is the low side, and then we will power it down. We'll go to this and replace at least that chip, probably both of them, check the driver board, reinstall it, put a couple of, hopefully these FETs right here that I need to test. We'll just tack them to the board where they need to be. So one will be in this bank and one will be in this bank, same on each side. Watch to make sure it develops both the high side and the low side, because this is a Class D amp. And if that's all good, then we can actually run a test signal through it and hook up a speaker for just a momentary super low volume to make sure that it's not got some kind of distortion somewhere, that anything went wonky here. And we'll check for the voltages on the op amps, which should be plus and minus 15 volts. But hopefully this is a straightforward repair where we replace those drive transistors, because they come from the TL494. So we replace those little banks of drive transistors that drive all these banks, and then we replace these chips on here. and I'll have to do an inspection of this board. If everything looks good, I might be able to get a fixture to hold this up and make it to where I can desolder this, and I'll show you how to do that if I can get it. I'll try to prep a little better for the next live stream, and that way we can get some more accomplished things. So I'll try to have these resistors swapped. It'll just be desoldering them, clean out these holes, and drawing the picture. I'll get a nice picture up here to put for these, and showing the layout and whether or not these match the pin layout of this style. If they don't, I'll show you how I bend them to make them fit in there, if these fit in the hole, because the legs are a little bigger. Hopefully the holes in here will be big enough to take them, and we can just beef this up. So beefing up the drive circuit and actually using the 3205s will actually make this a good strong power supply, hopefully able to handle if somebody ever pops the output again. Maybe it will survive long enough for protection circuit to kick in, so if this amp was to ever eat it again, you just have to rebuild the output. But I'm going to call it a night because I got a phone call from my mom. She's left me a voicemail, and so it's around the holidays. Don't want to be a terrible son and not call her. I want to say we'll pick up tomorrow night. Kind of late. Maybe we'll do an hour-long stream if I can get some of this stuff prepped, because I'd really like to cover this, then show all the good drive, at least put a couple FETs in, show that we get power, and check all the rail voltages, do all that checking, and then maybe even slap a pair of these in for testing if these turned out good. I'll try to get myself a little better organized. Otherwise, it will be sometime this week. I'll get it organized so that we can hit major points and have good answers to questions or stuff like that. So, but I truly appreciate everybody stopping in and watching and asking all the questions. Come up with more questions, and tell your friends if they have questions. Like, comment, subscribe, all that crazy YouTube stuff everybody does, but the comments are actually the fun part. Interaction. That's why I like this live streaming so much. Is I like the interaction. I like when someone like Anon. I'm not sure exactly how to say his name there. Anon. Asks a question, gets a good answer, and then he can go forward and learn something and do something. And I like it when people learn and get excited about doing things. So that's the fun of this, and I appreciate you. Thanks, Jason, and thanks, Cliff, and everybody else that was in the chat. And be careful going to work tomorrow if you're in the snow and cold areas. That's why we are. So it might be icy, and don't end up in the ditch, my friends. And have a good one.